Logarithmic functions, there's something you've probably never seen. Ever heard that word, logarithm?
Yep.
You've heard the word?
Yeah.
You've heard it. I said it a couple days ago. But do you know what they are? Okay, so the last week or so we've been studying exponentials, right?
Yep.
So I would maybe say graph and create a table for y equals 2 to the x. Right? So we could do an xy table. Come up with some x and y values, right?
1, 2.
And then we could also graph it.
Ooh.
Okay, you're okay with that? All right. Here's a question. What if I say when is the value of y equals 2 to the x 16? Because you need 16 equals some exponent of 2, right? Well, you can do that in your brains. 2, 4, 8, 16, right? X is 4. But what if it's really difficult and I ask you for some oddball number like 10,432?
Then you would just want to plug it into your calculator. Look it up on the internet. Just Google it. X equals.
Okay. So where would that come from?
24.
We have to solve those using logarithms. The short people in the back, bad idea. Okay. So what is a logarithm? You bet I am. Okay, so a logarithm is simply the inverse of an exponential. That's how we solve, right? So remember, inverse, what does that mean? What do you switch? Yeah, you switch the y's and the x's, right?
Yes.
So if I want to graph y equals logarithm base 2 of x, okay, log has a base which matches an exponential base, right? Ooh, imagine that. My x's and y's are just flipped. So if my y values are negative 1, 0, 1, and 2, my x's are 1/2, 1, 2, and 4. See how they just switch? Inverses.
When do you see this in the practice?
Okay.
He laughs.
You ever heard of the Richter scale for earthquakes?
Yes.
Logarithmic.
Scale.
Yeah. pH. Are you in chemistry? pH is a logarithmic scale. If we didn't have logarithmic scales, so earthquakes, a Richter scale earthquake of 1 has a power of 10 to the 1st. The 2 magnitude is 10 to the 2nd. A 3 is 10 to the 3rd. A 4 is 10 to the 4th. Right? So what's better for the news to say? This was a magnitude 8 earthquake, or this was a magnitude 10 million joules per second earthquake?
10 million joules per second
So
earthquake.
magnitude 8, because so they use a logarithmic function to generate that 8. It makes it a little bit more user friendly. Okay, so and pH is the same way, right? Concentration of hydrogen atoms in a solution. You might have 10 to the 8 hydrogen ions in a solution, but the pH is going to be 8. Okay, so there you go. Okay, and graphically, remember the x's and y's are switched.
Oh.
See, remember we reflect over this line, or we switch the x's and the y's, there's your inverse. So, pretty handy. Okay? Is this logarithm ever going to be have negatives in it?
No.
No. This is a vertical asymptote. There are no negative x values here. Okay? Log, the domain of a log function, x greater than 0. Okay? What's the range? Okay, yeah, domain. So all we have is x bigger than 0. That's all we can put in there. Logarithms are not defined for negative x values because exponentials don't have negative y's. Right? Okay. So what's the range of that function? Yeah. You got negative infinity to infinity. Okay, so a little info there. Okay, so that's the concept of a logarithmic function. Let's look at some things we're going to do to solve them. All right, so okay, so there's your comparison. Okay, see where the x is here in the exponent? It's the answer of a logarithmic function. The y is in a log function becomes the answer in an exponential. Okay, and then the bases are the same. Okay, so these bases are the same. Okay. So if I have something like log is 125 25 equals 2/3.
What?
That's a true statement. Can you rewrite that as an exponential? So how would I transfer from here to here? What's the y in here? Which number in here is the y?
25.
Yeah, the 25. Okay, so 25 equals what?
125 to the 2/3.
Base.
Right.
And then your x value.
Whoa.
What you calling?
That you know how to deal with, correct? Yeah, cube root of 125 is 5. 5 squared is.
25.
Oh, snap.
Oh, that's cool.
Yeah, of course it works. It's math. Math always works. You just got to know how to use it. Okay? What about this one? If I gave you that and asked you to rewrite it as a logarithm. And we'll use just log. We like shorthand.
So wait, that's the y equals x, right?
Yeah, so we are in this format now. Where do the numbers go?
So we got 3.
What's the base? 4? And then these you basically switch, right? So what goes here? Right? Because 4 cubed is 64. Here's something real interesting you might see. Is that true?
Yes.
Yeah, see this is 4 cubed, correct?
Yes.
So what is log base 4 of 4? That's 1. Okay, so we'll talk about the properties of logs and why those are equivalent here in a bit, but
They're very important.
that's why that works. Okay, let's solve some logs. So there are a couple ways you can attack these. One is to think them through logarithmically, or another way is to possibly think through them exponentially. Which would you prefer to start with? Okay, so we want to know what this equals, right? Okay, can you rewrite it as an exponent?
Shouldn't it equal x?
Oh, it doesn't matter. I could put z here. It's just a variable, right? So 7 to some power equals 1/49. Correct? Can you write 7 as an exponent, or 49 as an exponent of 7? 7 to the second. Right, so what's y equal? You remember exponents, if we want to move this to the top, what does the exponent become? Yeah. So y equals exponent, exponent, y equals -2. Okay. So that's solving exponentially. Okay. Using your properties of exponents. You agree with that? Okay, I see a lot of blank stares. Where are you stuck?
Is that still a y exponent by the 7?
Do you see the steps there? Anybody stuck somewhere? You're good.
Yes.
Okay. Here's the logarithmic way to look at it. 49 is 7 squared, right? And I can rewrite that as 7 to the -2, correct? Okay. That, those basically cancel each other out. Your answer is 2. So there's a couple ways to attack that. As you get more comfortable with logs, you might move that direction because it is a little easier or a little faster. Okay. Let's talk about radioactive decay. half-life?
Yeah.
Yeah? You've probably all heard of this. Who is in chemistry? Have you had to solve exponentials this year?
Well, actually, I saw some on the mom.
Yeah? Okay, now you're going to be able to do those. Right, so the half-life is an exponential function. Let's write it like they do in the math book. Okay, right, half-life, exponential decay. Thorium-234 is a substance that we can measure using its half-life. Okay, how long would it take for, let's say we have 256,000 grams to start. Half-life is 25 days. Okay, which is very fast, right? It's actually something we can measure, as opposed to something like, say, carbon-14, which has a half-life of somewhere around 6,000 years. And we're really just taking an educated stab at that half-life, because we don't have 6,000 years worth of data. Okay. So don't trust some of those calculations as much as you think. Okay, so the half-life is 25 days. How long to decay to 1,000 grams? So what do we need to plug into our function? What's n? Yeah, we got n here. And n0, yeah, that's the initial, right? And then 1/2 to the t. Now we can solve that using logs. Okay, so divide, right? Same algebra we've always done.
So it's asking what is the half-life at, how many?
At what? How many half-lives? This would be. Will it take for this to reach 1,000 grams? Okay. What's 1,000 divided by 256,000?
1/256.
Yeah, probably best to leave it as a fraction at this point since we don't know. Okay, so you have an exponential now, right? Rewrite it as a log. What exponent of 2 gets us to 256? So you can think about this either way. 2 to what power is 256?
8.
Yeah, it's 8. Or you can think of it in this way as well. It's the same thinking pattern, right? These are equivalent statements. So 8, and what are our units?
Years or days?
No, this is not days, this is half-lives.
Oh.
So how many days?
800.
200 days. Okay,
Fancy that.
be careful with that. All right, we'll go over the properties of logs tomorrow, and hopefully you find that useful on your AP test, or your AP test. Let's see that. Needs to be in calculus on your SAT. Okay, we're going to have it due tomorrow because I want to check to see if you understand it. Answer any questions you might have. Because if you have some questions we can clear up and you get a problem right in the SAT, that gives you a much more advantage, so.
Oh, yeah.
Logarithms, we'll talk more about them tomorrow. Do tomorrow.
Are you going back to Rock of the House now?